Good evening, everyone. Today I'm going to do questions from exercise 7.3 from question number 11, Art of Integration chapter. Cos power 4 2x, which we can write it as. So cos power 4 2x can be written as cos square x, cos square 2x the whole square. Cos square 2x using this formula we can write it as 1 plus cos 4x by 2. Then separate the square, so it becomes 1 plus cos 4x the whole square by 4. 1 by 4 is taken out. Expand 1 plus cos 4x the whole square using a plus b the whole square formula. This is almost same like the 10th question. So again we come across the square term. So use the same formula to convert from square form. So it becomes 1 plus cos 8x by 2. Try to simplify as much as possible and then start integrating the terms. So once you finish all the simplification, you come to this and then you start integrating some term by term. Integration of dx is x, integration of cos 8x is sin x 8x by 8, and 8 into 2 is 16. Integration of cos 4x is sin 4x by 4, and 2 by 4 is 1 by 2 later. That's it. Next question number 12. Integrating sin square x by 1 plus cos x. Sin square x, we can write it as 1 minus cos square x, which we can further split as 1 minus cos x into 1 plus cos x. 1 plus cos x will get cancelled. Remaining is 1 minus cos x. Now let's start integrating this. Integration of dx is 1. Integration of cos x is sin x, and since there is a minus, it's minus sin x here, plus c. So this is the 12th one. Now 13th one. 13th one is an important sum. Cos 2x minus 2 alpha, cos 2 alpha divided by cos x minus cos alpha into dx. Cos 2x and cos 2 alpha, using cos 2a formula, I can write or expand as 2 cos square x minus 1. Cos 2 alpha, 2 cos square alpha minus 1. Open the brackets, minus get cancelled. So we get 2 cos square x minus 2 cos square alpha. You can take 2 common out. So then it's a square minus b square form. As split it as a plus b into a minus b. Now put it back in the numerator place. It will get cancelled with the denominator term. Then the remaining is 2 cos x plus cos alpha. And then start integrating cos x, which is sin x. Cos alpha is a constant, will stay out of integration. Integration of dx is x. So remember, cos alpha is a constant. So you should take it out just like we took out 2. So integration of dx is x. So answer is 2 sin x. 2 times sin x plus x cos alpha plus c. 14th question. Integration of cos x minus sin x by 1 plus sin 2x. There is no direct integration for these kind of questions. We need to simplify this to a certain extent, only then we can start integrating them. So I have chosen the denominator first and then return 1 as cos square x plus sin square x. We know that cos square theta plus sin square theta is 1. So instead of 1 is cos square x plus sin square x. Sin 2x is expanded as 2 sin x cos x. Now this is in the form of a square plus b square plus 2ab, which is a plus b the whole square, nothing but cos x plus sin x the whole square. So denominator becomes cos x plus sin x the whole square. Now use substitution method. Take t as cos x plus sin x. dt will cancel the numerator. So it will be 1 by t square into dt. Now start integrating it. Substitute t back into the answer. 15th question, tan cube 2x into sec 2x. Tan cube 2x into sec 2x. Tan cube 2x can be written as tan square 2x into tan 2x into sec 2x as it is. Now tan square 2x can be expanded as secant square 2x minus 1. Now do not multiply this. If you multiply, you get stuck up there because you will not be able to integrate. So don't multiply, keep it as it is and consider t as sec of 2x. So follow substitution by considering t as sec 2x. So integration of sec square 2x minus 1 into tan 2x sec 2x into dx. I'm going to take t as sec 2x. So dt by dx will be 2 sec 2x into tan 2x. That means dt by 2 sec 2x into tan 2x equals to dx. So let us highlight the t term and the dx term. Substitute it in the question. You will get integration of t square minus 1 into dt by 2. 1 by 2 will stay out of integration. T square minus 1 into dt. So that means 1 by 2 of t cube by 3 minus t plus c. Substitute t back into the answer. So sec 2x cube by 3 minus sec 2x plus c. 16th question. This type of question is important even for 1 mark. Like sine power 4x, cos power 4x, tan power 4x, tan power 4x, all these are important questions. So tan power 4x, we will write it as tan square x into tan square x. And tan square x will be written as secant square x minus 1. Now multiply tan within. So tan square x into secant square x, tan square x into minus 1, that's minus tan square x. Now let us start integrating them, but make sure that the terms can be integrated with whatever you have. Well, when it comes to this particular term, if you take t as tan x, dt can cancel secant square x. So I have taken t as tan x. So if t is tan x, dt will cancel, dt by dx will cancel secant square x. So this one I am planning to do by substitution. But when I come to this is tan square x. There is no direct integration, but we can change tan square x to secant square x minus 1. So once I change it to that form, multiply the minus in. Now start integrating each and every term. Here only by substitution, whereas these two terms directly. So by substitution, this will come to a form of t square into dt, whereas the other two terms will be in terms of x only. So t cube integration is t3 by 3, secant square x integration is tan x, dx integration is x, plus c for the constant. Now t is tan x, substitute it back. 17th sum, sine cube x plus cos cube x by sine square x cos square x. This time I am going to distribute the denominator. So sine cube x by sine square x cos square x plus cos cube x by sine square x cos square x. Whatever terms are possible to cancel, cancel it out. So you get sine x by cos square x and cos x by sine square x. Sine by cos is tan, so we'll have still 1 by cos, which is sec. And here cos by sine is cot, still there will be a sine left, and 1 by sine is cosec. And now we have come to a point where we can directly integrate it. Integration of sec x tan x is secant x, integration of cot x cosec x is minus cosec x, and plus c for constant. 19th question. This one is an important question, so put a star mark to this. Highlight this question. It is 1 by sine x into cos cube x. Let us consider 1 as sine square x plus cos square x and then distribute the denominator. You will find some of the terms getting cancelled. After the cancellation, we get sine x by cos cube x and 1 by sine x cos x. Now sine x by cos cube x is nothing but sine by cos tan 1 by cos square secant square. And here again 1 is written as sine square plus cos square. So separate the terms, sine square x by sine x cos x plus cos square x by sine x cos x. Now try to cancel whatever is possible. So we get sine by cos in the remaining and cos by sine here. So that's nothing but tan and cot. Now just see whether all the terms can be integrated or not. The first one, if I choose to take t as tan x, the dt will cancel secant square x. So substitution method is followed only for the first integration. This is not applicable for the second one. Second one, we already know that integration of tan x is log sec x and integration of cot x is log sin x. Since the log terms are in the form of log a plus log b, this will become log ab. And log ab, where sec is sine, sec is 1 by cos, 1 by cos into sine is sine by cos, and sine by cos is tan. So the end answer is tan square x by 2, that is after substituting t, and then plus log mod tan x plus c. Next question, integration of cos 2x by cos x plus sin x the whole square. Now this one is simple. By now you must all be comfortable with the formulas. So cos 2x can be written as cos square x minus sin square x. Then splitting this as a plus b into a minus b. Then this and this will get cancelled, one of the term. Remaining will be there. So cos x minus sin x by cos x plus sin x. Then take this as t. dt will cancel the numerator. So this will become 1 by t, and integration of 1 by t is log t. And substitute t back. So that 21st question is sine inverse cos x. Now we can cancel sine inverse cos x only if I change this sine inverse to cos inverse form or switch cos x to sine form. The best way is to change sine inverse to cos inverse form. There is an identity available for that. Sine inverse x plus cos inverse x is pi by 2. Here x role is played by cos x. So sine inverse cos x can be written as pi by 2 minus cos inverse of cos x. Cos inverse of cos x is x. So instead of sine inverse cos x, we will change that to pi by 2 minus x. Now start integrating dx, which is x here and x square by 2. 22nd question, 1 by cos of x minus a into cos of x minus b. Highlight this question also. This is also an important question. The same type of question is there in the miscellaneous exercise. So when we do the miscellaneous, we will have this sum. We will relook at this question one more time. Now, since it's a cos version in the denominator, I'm going to multiply with sine. If it's cos of x minus a into cos of x minus b. Forget about x minus a and x minus b. If it's cos, we multiply with sine term. If it is cos sine or sine cos, we multiply with cos. So here I multiplied and divided with sine of a minus b. Then a denominator sine of a minus b is taken out. Numerator is over here. Inside the angle, inside the bracket, I am adding plus x and minus x. Then I am grouping this so that I can get something like this in the numerator. So my grouping is purely based on what is there in the denominator. So I look at this step and group it according to that. So now I group it like sine of x minus b minus sine of x minus a, which is nothing but sine of a minus b form, which is sine a cos b minus cos a sine b. Expand it and separate the term. Few will get cancelled. The remaining will generate tan values, tan of x minus b into tan of x minus a. Then start integrating it. Tan is sec and tan is sec, log sec. Integration of tan is log sec. So log sec x minus b, log sec x minus a. Now if it's log a minus log b, it's log a by b. So it's log a by b form. This is okay, you can leave the answer this way, or we can change sec to cos. In that case, the denominator will come to the numerator and numerator will go to the denominator. So it will be log cos x minus a by cos x minus b plus c. The next question is 23rd one, wherein it is given sine square x minus cos square x by sine square x into cos square x. We did 2-3 sums of the same pattern. So just separate the terms. Write it as sine square x by sine square x by sine square x cos square x minus cos square x by sine square x cos square x. Some terms will get cancelled. Remaining will take you to a step where you can comfortably integrate. So 23rd, I think you all will be able to do it on your own. Now let's get into 24th one. Integration of e power x into 1 plus x divided by cos square into cos square of e power x dx. Now here take t as e power x into x. Take t as e power x into x. When you do that, when you take t as x into e power x, the dt by dx, the differentiation, will be e power x into x plus 1. So eventually the numerator term will get cancelled. So therefore the sum will get transformed to dt by cos square t, because you have taken e power x into x as t, so this will become cos square t. 1 by cos square t integration, before integrating take it as secant square t, then integrate it, so tan t, substitute t back into the answer. Exercise 7.3 is completely over. Hope you understand each and every sum very well. Try to practice it more, and if you like my channel, subscribe. Share it with your friends. Thank you.